Hi, my name is James Dean Vogel of the BioProcess Institute, and this is Between Two Ferals. Today, we're going to have Luke Coxon, Global Product Manager of Mixing Systems for Sanisure, to talk to us about their Mixed4Sure product. So let's welcome Luke. Welcome, Luke, to the BioProcess Institute. Glad to have you here. So Sanisure has been up to a lot of things and a lot of exciting products. I know you were recently at the Boston ISPE show and had a lot of activity I think you had 1 or 2 booths there, right?
We have 2 booths, that's right.
Yeah, so lots of folks visiting and lots of things happening, so that was great. We'll move a little bit this way. So maybe you can give us a little background on this product that we have here, the Mixed4Sure, and something about how it works and its intended focus.
So firstly, thank you very much indeed for arranging this. I appreciate the opportunity. To your point, this is the Mixed4Sure. This essentially is our newest mixing product. We have created it from the ground up, or developed it from the ground up, to be a process vessel. So really, we see this being deployed in many developmental, clinical, and also commercial biomanufacturing mixing steps. It offers all of the contemporary features that a modern bioprocess would expect. So we see conventional sensors being utilized for pH and conductivity, as well as the unique heat and cooling finger, which is present for the purposes of thermoregulation.
Perfect.
Every single version benefits from the same consistency in terms of the ability to be able to mix at very, very low mixing volumes. So that means that you have complete flexibility in terms of your working volume for the process vessel. It's available in standard configurations from 500 milliliters all the way up to 20 liters.
Wow, 20 liters. Okay, very good. And is this a 10 liter?
This precise model is a 10 liter.
Okay.
And I think when Sanisure developed this product, we intended for it to be kind of like the Swiss Army knife of single-use mixing vessels. So we saw it being deployed in buffer and media preparation steps, harvest homogenization, throughout the entire bioprocess chain. And I think with the benefit of some experience with the product in the market, what we've found is that the value proposition that's offered by the technology is much more suited to late stage downstream and formulation fill finish.
So more critical applications, where the value of the product is very high, and thus they need the precision of what you're offering.
Yeah, so the rigid container that's offered by the Pharmatainer means that you have real consistency when it comes to lot reproducibility, because your vessel is consistently has a consistent geometry each and every time you execute the mixing step. In addition, as I say, we have created some data recently which demonstrates really good performance, both in final formulation mixing because of the characteristics of low volume mixing, of excellent product recovery characteristics, but also for vaccine formulations where alum-based adjuvants are being used. We've created some very compelling data where the Mixed4Sure has been used to maintain adjuvants in complex with drug substance at the appropriate level recommended by the FDA.
Okay, and so basically this mixer allows that. Is it a suspension, or just that when you set up the initial mixing, they stay in solution better?
Precisely the second.
Okay.
So essentially the FDA expects there is no minimum expectation in terms of complexation, so the higher the better. And we've been able to achieve values of over 85% for this technology. So of course, that in combination with the minimum mixing volume being so low for this device means that you are able to maintain that suspension all the way down to the last few milliliters of fluid, which means that during your drug substance, or pardon me, your drug product filling, you're able to guarantee that homogeneity per individual dose of product.
Perfect. Now, when you make these apparatus, are they all molded, or do you do some fabrication things to get the ports and the things that are in here?
Great question. Great question. Yeah, so it is a fabricated product. The bottle itself is manufactured in our facility in Luxembourg. The Pharmatainer bottle comes with some it's the cleanest bottle available on the market. It's a completely automated manufacturing process performed under ISO Class 5 environment. So we have successfully qualified the process to offer really limits of detection, below limits of detection for particulate and endotoxin. We then take these into our facility and we perform a process known as fabrication, which is creating all of the necessary ports to integrate all of the other components that you see. So the swabbable sample valve, so needle-free sample valve, the mount for the heating cooling finger and the heating cooling finger opening, the mounts for the sensor ports. Now what that process means is that we're unable to offer quite the same levels of cleanliness.
Sure.
But the product still meets the USP 788 compliance requirements for subvisible particles.
Okay, very good. And I know the Pharmatainer proper has a fairly good pedigree in your qualification package because we assisted you with doing the extractables and so on.
Yeah, absolutely.
So you have a lot of that back, which is great.
And we've built upon that position. So absolutely, the BioProcess Institute was responsible for executing USP 665 testing for the Pharmatainer. But we've set a minimum expectation that every component within the assembly also meets the USP 665 criteria. So with the expectation being that the USP 665 guidelines will be published and then become a compliance burden for end users starting in May 2026.
Yep.
SaniSure leveraged the opportunity to bring a technology to market where that was the minimum requirement for all of the components used in the assembly.
That's truly an industry-leading position. That's great.
Precisely. I mean, we've leveraged where we can sub-supplier data. That's not always been possible. Not all sub-suppliers have that data, or they're not as well prepared as perhaps they should be. And we've taken that responsibility to create those data packages ourselves.
Okay, it's getting better, but it's still not perfect, and you're filling the gaps. Yeah. So that's great. We talked a little bit before about the 788 testing, and so particulate. So one thing is when you go through that fabrication step and you add the ports and all, you must do something to mitigate particles from that step or something.
Yeah, we absolutely do. So while we're not able to, it's a very manual process. I mean, much of the business that we do today involves custom assemblies. So this is an example of a standard which involves a lot of fabrication, but we also respond to specific customization requests to make sure that our products are application focused. We can't automate the process in the same way as the Pharmatainer manufacturing process. So in order to mitigate particle risk, we have what are known as clean cubes, which are very small laminate airflow cabinets where the fabrication or the porting performance
is all performed in that cabinet. Yeah. Okay.
And then as a final step, after all of the porting has been performed, we will perform an air blowdown using deionized air.
Okay.
And that removes any adhered particles.
And you've done testing post that to prove that.
Absolutely,
very good.
Yeah. So
very good.
Two ways we've addressed that. So firstly, we wanted, of course, to make sure that our manufacturing process was in control. So we performed USP 788 to demonstrate that the manufacturing process wasn't generating subvisible particles. We, of course, during the manufacture of any of our products, we execute visible particle monitoring. We can, as an elective test, have USP 788 testing performed per lot for customer.
Okay.
But then in addition, obviously because there are moving parts in the mixer, moving parts generate friction, friction generates particles. We had one of our larger biotech customers perform USP 788 testing in operation. So we have, or they were responsible for executing the testing for up to 8 hours of continuous operation, and it still met the requirements of the farm.
Okay, so your agitator is a magnetic drive, as we
Correct.
can see here. So then you must have some type of bushing or bearing, I guess, low
That's right.
friction or something that provides that those particles are within, you know, the requirements of 788.
Yeah, and one of the things, so the design of the impeller went through a number of different iterations, both in terms of its geometry, but also in terms of its materials of construction. And really, the sweet source of the design here is making sure that we have a really strong material science in terms of the selection of components. So the impeller head, the agitator, is manufactured from PEEK. That's really good plastic material because it's very, very hard, high performance. The bearing, as you quite accurately point out, is made from PPSU, and the combination of those two materials ensures that we get very high performance but also low particle generation.
Excellent. Well, obviously well designed. With the design, what about the probes and I guess response for either mixing studies or things that happen from pH, or I don't know how maybe you've looked at that?
Yeah, sure. So, I mean, I'll just maybe talk about the heating cooling finger.
Oh, I'm sorry.
No. So the first item we have here is this long stainless steel 316L stainless steel temperature finger that is covering the entire internal geometry of the bottle. We've performed some heating and cooling curves to demonstrate that this is capable of operating within the expected range of the Mixed4Sure bottle itself, so 2 to 40 degrees centigrade. The cooling curve specifically targeting that sweet spot in the 2 to 8 range, which is conventional for a lot of biologics.
Okay, and that pretty much the cooling's done by an external bath or something to come in?
It's done by a fluid recirculation, Luke, from a temperature control unit.
Yeah.
So propylene or ethylene glycol is recirculated through the component, intimate contact with the process solution, which enables the rapid cooling, or if the process requires heating.
Excellent.
We then have single-use pH and conductivity sensors integrated into our standard assemblies. The conductivity sensor obviously is there as a measure of homogeneity, covering the mixing step. The pH sensor, because pH adjustment is, or maintaining pH in a given range is often important in the late stages of production. You see pH being a critical process parameter in a lot of UFDF processes, for example. And actually, we can show some acid being added to the vessel to show the response curve. The sensor itself is capable of connecting using some reusable or multi-use equipment to a laptop or alternatively wirelessly to a smart device. And if you see the response curve available, you'll notice that there is obviously a pH response over time.
So your interface to the laptop, that comes straight from the probe, and you supply that software or utilize an open architecture?
The probes are supplied to us by Hamilton, and they have some free-to-use software that they make available to all end users called the ArcAir. That comes with some data hardware which can connect up to a laptop computer to be able to transmit the signal. And of course, you know, it's very important to consider that sampling is at the core of every single bioprocess. So we've incorporated a needle-free sample valve at the bottom of the bottle at a low point, which is there specifically for the purposes of sample in-process samples to maintain any stability or retain samples that are required, but also for offline monitoring of process characteristics. And
then for the product removal, right now this configuration has the DipTube that would be used for the product removal.
This again is a proprietary Sanisure component called the last drop DipTube. Under worst case conditions, and I'll explain what that means in a moment, we've been able to achieve greater than 98.5% of recovery of the process volume. So worst case, what we mean by that is essentially two things. Firstly, that no air bubbles are entitled to enter the flow stream, because that can be problematic for a process. And secondly, that there's no manual manipulation of the bottle. If those two criteria can be changed, it's permissible to change them, then we can essentially recover, almost 100% of the process volume.
Brilliant. Brilliant. Well, it obviously is an impressive product. I have to say, I really see applications. I see applications for this in multiple areas. So, obviously you've talked about it on the product side. I could see for development labs, it's a very compact setup piece of kit that somebody could get, and with the simple instrumentation that you described, get a lot of data out pretty quickly.
Yeah, I mean, absolutely. And one thing that I personally am very proud of is that this continues to be a real center of Sanisure's development pathway. So we're continuing to develop it and continuing to invest in the performance of the product. I think when we originally conceived this, I mentioned that we wanted to qualify this as a process vessel that would be used in commercial bioprocesses, and we also conceived it as a kind of Swiss Army knife for biomanufacturing unit operations, so buffer media prep, and it's important that as we've gathered some more experience, it's more suited to critical mixing. With those critical mixing steps comes a need for process scalability as well. Now, with the Mixed4Sure standard range as it exists today, we have a partial scalability claim. So we have consistent chamber geometry that's offered by the Pharmatainer, so same footprint to
height to footprint
ratio, exactly.
Right.
But then we also have the consistent materials of construction, so the Pharmatainer, the 316L stainless steel, the polypropylene of the other components. Where we do not today have that linear scalability is that in our small volume mixers from 500 ml to 2 litres, we have a 1.25 inch impeller, and in the volumes 5, 10 and 20 litres we have a 1.9 inch impeller. So we have a step change in the middle of the volume range. We are creating the mathematical model necessary to offer that linear scalability to end users, and that will initially be within the range, but we're aiming to offer that beyond the maximum volume as well, so scaling into other mixing technologies.
Nice, very, very, very nice. One thing that comes to mind is, so when this is purchased and what one gets, is it like this, or does the end user assemble it and sterilize it, or does it come pre-sterilized? How does one get the...
Another fantastic question. So everything that we ship from our existing range is gamma irradiated, ISO 11137 qualified process, double wrapped in a 2 layers of polyethylene, so staged into a clean room environment. And the idea is that we want to really simplify it, so it's intended to be
ready to go,
ready to use.
Just add your product and move.
Yep.
Okay. Very, very good. Well, it's definitely an impressive product, and I think something that if you have any needs in this area, Sanisure has again shown their leadership in this area in multiple ways. I guess just to close, Luke, is there anything from your experience? We always like to try to get something. I teach at the university to the younger folks. Any advice you would give a young person coming into this field as to what he or she might want to do to be a little more successful or get a leg up on someone?
Yeah, I mean, my advice, unfortunately, is going to be very, very general here, but it's always going to be just stay curious. Ask questions every single day. Challenge the norm, because that's how we progress, I think.
Sure, and that's part of why we have the CGMPs, is to stay current. Things evolve, technologies evolve, and so I think that is good advice for the young people, is try to bring that there, and bringing, maybe you have limited experience, but ask those questions, as Luke said.
Yeah, and I also would add to that, stay curious and maintain a positive attitude and assume positive intent.
Okay. Very good advice, very good advice. Well, again, thank you for coming. It's been a great talk, great product. Look forward to working with you some more.
Wonderful, thank you.